Good afternoon, everyone.
Afternoon, sir.
Okay, let us start. Remember, we have been learning Chapter 2, the origin and the evolution of the art of our NCERT textbook, Fundamentals of Physical Geography. In the last class, we discussed about the origin of the art and the universe. And today we shall discuss about evolution of the art. Now I shall share my screen. So, can you see my screen?
Yes,
Okay,
sir.
okay. So
Yes, sir.
okay, good. Then before we start discussion about the evolution of the art interior, so let us revise about our solar system. I think solar system, you are very much familiar with it because you have learned in the lower classes also. So we know that we have 8 planets in our solar systems, and these 8 planets are categorized into two groups. Okay, the first 4 planets, that is Mercury, Venus, Earth, Mars. So these uh, 4 planets, the first 4 planets are named as terrestrial. Okay, terrestrial planet. So terrestrial means Earth-like. Okay, Mercury, Venus, Earth, Mars. So these are known as terrestrial planets. Terrestrial means Earth-like. And the remaining 4 planets, that is Jupiter, Saturn, Uranus, and Neptune. So these 4 planets are known as Jovian. Okay, Jovian. Jovian means Jupiter-like. Okay, and so you may read this table about the density, about distances, about radius, and the number of satellites. So you may read. And next we have origin of the moon. Okay, so our moon, this is the only natural satellite of the Earth. And for the regarding the origin of the moon, the most widely accepted hypothesis is the big splat. Okay, the big splat theory or the hypothesis. Now, so let me show you one photo. I mean picture. Okay, see here. Actually, see, this is the big splat simulation model. Okay, so here one very big celestial body, asteroid, say having the size of the present the Earth, heat on the Earth. Okay, heat on the Earth. I think you may be seeing here. So this is the body, that asteroid having the size of the Mars. So it hit on the Earth. Okay, and accordingly, see from the surface of the Earth. Okay, materials were ejected, and just one more. Okay, let's see here. So the name of the asteroid or the celestial body was named as Theia. Okay, so this is the asteroid. Okay, which hit the Earth. Actually, during those days, the Earth axis was vertical like this, and after hitting the Earth, okay, by this asteroid Theia, just see here, I think you may be seeing here, okay, because of the impact, because of the this impact, our Earth axis was tilted like this. Okay, I think in the present world our Earth is tilted by about 23.5 degree, okay, to the orbital plane, from the vertical axis, from the vertical plane, and the 66.5 degree to the orbital plane. And because of this impact by the asteroid Theia, so materials were ejected, okay, and thus continue to revolve. So this is the axis, thus continue to revolve around the Earth, and so these debris, these materials from the Earth, okay, coalesces, means combine together into one body known as the Moon, the only natural satellite of the Earth. So this is what we call the big splat theory, or the hypothesis, or the great impact. Okay, and so it took about 4.44 billion years ago before present. Okay, I think you'll find here the great impact, the deep impact took place by about 4.44 billion years ago. So this is about the origin of the Moon.
Wow.
Okay, so any question, boys and girls?
No,
Okay,
no,
then
sir.
next we have about the evolution of the Earth. Okay, see, you must know that our Earth was initially, okay, our Earth was initially this barren, rocky, and was a hot object with thin atmosphere of hydrogen and helium. That means the early Earth actually was very much bigger than the present day Earth, and it was in the volatile state also. It was loose and hot, and the atmosphere also mostly composed of hydrogen and helium, very light and inflammable gases. Okay, and now we shall discuss how these different layers of the Earth interior develop. That is about the origin of the lithosphere. Okay, so now see, I will show you one diagram. Just see here. Actually, see, it was the early, this is the early Earth, okay, the primordial Earth. And at that time, after the Big Bang, okay, and after the origin of the, after the formation of the solar systems and the other planets, all these planets and the satellite were in a volatile state, okay, and undifferentiated in the gas of magma, means no layers in the Earth's interior were there. That is undifferentiated uh, magma ocean was the major constituent of the Earth. But in due course of time, okay, the temperature of the Earth drops, and accordingly, see, very these heavy metals like iron and nickel, okay, sink uh, towards the center, and whereas light materials like aluminum and silicate, okay, rises upwards, and this process is known as differentiation. Okay, so remember, heavy metals like iron, okay, and nickel, like this iron and nickel sunk downwards and towards the center, and the lighter ones like silicate and aluminum, okay, silicate and aluminum rises upwards, and thus depositing here at the surface, thus forming the crust. You know, the main constituent of the crust is silicon and aluminum, and after just in the lower layer of the crust we have silicon and magnesium. And as I told you, the heavy metals like iron and nickel, okay, sink downward toward the core, and thus forming this core consisting mainly iron and nickel. And in between these crust and the core we have a transition layer known as mantle. Okay, this is the transition layer, this is the outer core, this is the inner core. And so this transition layer contains a both. Okay, so this is the present day layers of the Earth interior. I think in the lower classes you have learned about the 3 layers of the Earth, that is the crust. Okay, just see here.
Mental.
Yes, this is the crust. Next, in the middle we have mantle, and in the interior, in the center, we have the core, right? So
Yes, sir.
this is how the layers, the 3 major layers of the Earth were originated. And the process of layer formation is known as differentiation. Okay,
Different.
differentiation. I think you'll find here in your text. So see here, differentiation. Okay, the process of differentiation. Are you clear? Any question, boys and girls? Okay,
No,
then
sir.
okay, then next, I think
Sure.
you have learned about the evolution of layers, and now let us discuss about the evolution of the atmosphere and the hydrosphere. How the present day atmosphere and the hydrosphere evolve. Okay, and see, when we talk about the evolution of the atmosphere hydrosphere, we have to read this small paragraph. And here it is mentioned that there are 3 stages in the evolution of the present atmosphere. So the first stage is marked by the loss of primordial atmosphere. And in the second stage, the hot interior of the Earth contributed to the evolution of the atmosphere. And finally, the composition of the atmosphere was modified by the living world through the photosynthesis. So these are the 3 stages about the evolution of the atmosphere. So in the first stage, that is, see, in the first stage was about the loss of primordial atmosphere, early atmosphere. And as we have learned earlier, that the early atmosphere was mainly composed of hydrogen and helium. Okay, and is supposed to have been stripped off, to have been wiped off as a result of solar winds. Okay, see, this solar wind, this is electromagnetic waves, okay, radiated by the sun. And let us say this is the Earth, and it was surrounded by these hydrogen and the helium gases. Okay, hydrogen and the helium, these are light gases. Because of the solar wind, these light gases were stripped off, wiped off from the surface of the Earth. Not only from the surface of the Earth, from the other the planets also, because of the impact of the solar winds, these early atmospheric gases were wiped off. Okay. Then in the second stage, what happened? Just see this diagram. In the second stage, see, through the volcanic eruption. Okay, through the volcanic eruption here. So one volcanic eruption is here, another here. In different places of the world, there were lots of volcanic eruptions. And through the volcanic eruptions, see, water vapor, then carbon dioxide, okay, mainly ejected, and sometimes methane also ejected. Okay, and see, in due course of time, the temperature of the Earth also drops. Then the temperature of the atmosphere also drops. And so we also have known that water vapor is also ejecting from the Earth's interior. And because of that, see, clouds will form. because of cooling of the atmosphere, clouds were formed, then there were rainfall. Okay, and these rainwater fill up, okay, the low-lying areas, the depressions, and thus forming lakes and the oceans. So this is a very long process, but you must know that the gases like water vapor, then oxygen, carbon dioxide, all these were ejected from the Earth interior through the volcanic eruptions. And this process of ejecting gases from the Earth interior is known as degassing. Okay, degassing, degassing. Can you see degassing? Degassing. I think this is the spelling. So let us see. It is here. Here. Okay, degassing. The process is known as degassing. Okay. See, early atmosphere largely contain water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little free oxygen. And all these were outpoured from the Earth interior through the volcanic eruption, and the process is known as degassing. And the continuous volcanic eruption contributed water vapor and other gases in the atmosphere. Then the Earth surface cooled down. Then Earth atmosphere cooled down. Because of that, clouds form, okay, by condensation process, okay, and carbon dioxide in the atmosphere also got dissolved in the rainwater, and because of that absorption of the carbon dioxide by rainwater, okay, temperature again further drops, and as I told you, the rainwater again got collected into the depressions, and that give rise to oceans, seas, and lakes. And you must know that the Earth oceans were formed within 500 million years from the formation of the Earth. Okay, and these tell us that it means that oceans are as old as 4,000 million years old, and sometimes around 3,800 million years ago life began to evolve in the oceans. And after that, because of the photosynthesis process, okay, so after growing plants in the oceans and on the surface of the Earth, and through the photosynthesis process, okay, we mainly got oxygen. This is a very long process. Okay, the early atmosphere mainly contain this water vapor and carbon dioxide, and the carbon dioxide again dissolved by the rainwater, and thus decreasing the volume of the amount of carbon dioxide in the atmosphere. And so after the origin of the life, after the origin of the plants, then because of the photosynthesis process, we got oxygen. Okay, and eventually oceans were saturated with oxygen, and 2,000 million years ago oxygen began to flood the atmosphere, thus forming the present day atmosphere. So this is about the origin of the present day atmosphere and the hydrosphere. Okay, up to here, any question, boys and girls, regarding the origin of the atmosphere and the hydrosphere? Remember, we have three stages. In the first stage, the early atmospheric gases like hydrogen and helium were stripped off by the solar winds. Then in the second stage, gases like water vapor, nitrogen, carbon dioxide, methane, ammonia ejected from the Earth interior through the volcanic eruption, that is called degassing. Then after further cooling down of the Earth atmospheric system, then cloud form, then rainwater got filled the depressions on the surface of the Earth, thus forming oceans and lakes, seas. Then about 3.8 million billion years ago, life originated, and only after that, because of photosynthesis process, we got enough oxygen. Okay, so this is the story. So any question, boys and girls?
No, sir.
Okay, then next we have about the origin of the earth. Okay, how life was originated on the earth. Okay, so here, this is the last phase. Origin of the life is the last phase in the evolution of the earth. Okay, and actually, we have learned that the early atmosphere was not conducive for the development of life, because it was mainly constituted by hydrogen and helium. But eventually, afterwards, we got this carbon dioxide, then oxygen, and some other gases like methane. Okay, required ammonia also, we got it, which are required for the origin of the life. So modern scientists refer to the origin of life as a kind of chemical reaction which first generated complex organic molecules and assembled them. The assemblies was such that they could duplicate themselves, converting inanimate matter into living substance. So you must know that life originated only in the water. Okay, so it is believed that life originated in the ocean water, and life was originated only because of chemical reaction in the water. Okay, because of that chemical reaction, inanimate objects, okay, inanimate matter converted into organic, that is animate matter. So here about the origin of the earth, so we have a famous experiment here. Okay, a very famous experiment. Just see here. Actually, so he was a great scientist. Okay, his name was Stanley Miller. So when he was a student of science graduate, okay, at the age of 22, so he performed one experiment. Okay, very famous, and most of the scientists also believe it. Okay, this is about the origin of the this origin of the life. Just see. So this is the schematic diagram here. So this is the apparatus used by him when he was a student, and this is the diagram here. And just see here. So in a glass, what to say, glass dumbbell shape bottle. Okay, here he fill up water that is simulated with the ocean water. Okay, it is simulated. So let us assume as a ocean water, and it is heated. The ocean water is heated. Then after heating, then vaporizes here. Water vaporizes, and here let us say in the atmosphere, water vaporizes, and he added this carbon dioxide, methane, ammonia, and hydrogen. Okay, so he added these gases into the simulated atmosphere. Then after that, here, this is the simulated atmosphere, and here he gave these sparks. It was akin to lightning process. You must know that lightning was very important. Lightning in the atmosphere, okay, thundering and lightning was very important for the origin of life. Okay, so in the atmosphere, early atmosphere, there were thundering and lightning, and because of that process, say chemical reaction took place between these gases and the water vapor. Okay, so here the water vapor in atmosphere condenses, and again it is falling down as a raindrop, and here we have a trap, and here in this area, in this trap water, these organic molecules are created, such as amino acid, for example. Okay, and from these organic molecules, life originated. So this was the experiment performed by Stanley Miller. So here we have one more text here. Okay, So this is the text, and just see here. Let us read the text, okay? Just see here. Let us read this area. Okay, this area. Okay, let me open another one. Just see here. See this area. Life is thought to have begun in the oceans. Stanley Miller's experiment showed that ultraviolet radiation from the sun and the hydrogen, carbon dioxide, methane, ammonia, and the inorganic molecules from the oceans may have combined to produce organic molecules such as amino acids. So according to Stanley Miller, these ultraviolet rays, then sunlight, hydrogen, carbon dioxide, methane, ammonia, and other inorganic, non-living, inorganic molecules combine, reacted together to produce organic molecules, living molecules such as amino acids. According to his, actually he has also got it as per his experiment. So a certain combination of these molecules eventually produce heterotrophic organisms. Heterotrophic means which cannot make their own food, and that were probably similar to the present day anaerobic bacteria. And eventually autotrophs evolved that had ability to make their own food through the chemosynthesis, and later some cells developed say chlorophyll, which made photosynthesis possible and led to the development of plants. Chlorophyll, the green pigments in the plants were formed, and because of these photosynthetic organisms altered the environment by extracting carbon dioxide from the atmosphere and also by releasing free oxygen, thereby creating today's oxygen-rich atmosphere. And eventually both plants and animals evolved to form into forms that could survive on the land. So this was how life was originated. Okay, and remember it can be assumed that life began to evolve sometime 3,800 million years ago. Okay, life was originated about 3.8 million years ago. Okay, so this was about the origin of life. Are you clear? Any question, boys and girls?
Yes, sir. No.
Okay, then just this table read yourself. Okay, geological time scale. You must know that in geography, time is divided into different scales. Different periods. The biggest unit is known as eon, and it is subdivided into era, again further subdivided into period and epochs. And remember the oldest, the earliest one is here. Okay, origin of the stars and supernova that took place between 5,000 to 13,700 million years before present. Okay, and just see here, now we are here, modern man. So now we are living in the Holocene. Okay, we are living in the Holocene epoch. Holocene means from 10,000 from present day to 10,000 years before present. So we are in the Holocene, and our period is known as Quaternary. Okay, so you may read this table, and you'll find the origin of the plants. Okay, major events of the origin of the plants and animals you'll find here. When was the frogs and the turtles originated? That's the Triassic period. Dinosaurs were originated during Triassic. Dinosaurs were extinct in the Cretaceous period. Okay, so read yourself. Any other question, boys and girls?
No, sir.
Okay, then let us stop here
Sir.
for today. Thank you very much for joining my
Sir.
class.